The question says that an infinite line charge produces a field of 9 into 10 to the power 4 Newton per Coulomb at a distance of 2 cm. Calculate the linear charge density. So we have to calculate the linear charge density given that the infinite line charge produces a field of 9.9 into 10 to the power 4 Newton per Coulomb. So let us assume that this is the infinite charge line, and at a distance of 2 cm away from this line charge, the electric field is of this much magnitude is produced. So what is the linear charge density, or lambda? Lambda is defined as total charge divided by length of the line. So we have to find out this value of lambda. Now we have an expression for electric field due to an infinite line charge, and that says that E is equals to lambda by 2 pi epsilon naught r. Now we can find out lambda using this expression, and that would be given by E into 2 pi epsilon naught r, and using this expression we have got the value of as lambda as 0.1 microcoulomb per meter. Now how this expression came, let's understand it a little bit deeper. Now let's assume that this is the line charge. In this question it is of positive charge, so we can assume it as a positive charge. Let us assume that there is a point r at a distance of r away from this line charge. Now we have to find out, either we have to find out Q, that is the charge on this line, or we have to find out electric field, or we have to find out flux. Now we can use Gauss law over here. Now we can assume a Gaussian surface, a cylindrical Gaussian surface over here of radius r. Now electric flux outward of this upper and lower face of the cylinder would be 0, because electric field would be perpendicular, so it would be 0 from this face and this face as well. So the only electric field contribution would be from the curved surface area, and from the Gauss law we know that flux is given by Q enclosed divided by epsilon naught. Now flux is defined as E multiplied by surface area. So E dot the curved surface area of cylinder is equals to 2 pi r multiplied by length, or the height. This is the length. That would be equal to Q enclosed. Now Q enclosed would be given by lambda times L. Lambda is the linear charge density multiplied by length L divided by epsilon naught. Now here we see that the expression of E would become L would cancel out each other. Now lambda divided by 2 pi r epsilon naught. Now this is the same expression we used in the upper question to solve the question. So it comes from here as per the Gauss law. Thank you.